Hi, I'm Bob Pryor. I'm talking to you today about the unit circle. We're putting all the ideas that we've learned together. And first of all, asking the question, what are trig values anyway? And the simple answer is that they are real numbers, and they have no unit of measure. So trig values are the values that we get after we take the sine or cosine or tangent of something. In this example, sine of theta opposite over hypotenuse is 4 inches over 5 inches. We divide out inches, as you can see here, and we're left with just 4/5. This is a real number. So it's a ratio of two sides, but it's a real number, and it's got no unit of measure. So as a function of, in algebra or in trigonometry, we have an input value, and the input value is called the argument. And we can see here that the argument of a trig function can be radian or a degree measure. And the output, the value that we get after putting in the argument, the output value is a real number. And it could be a number like -1, or it could be a fraction, or it could be a square root, like square root of 3. These are the real number trig values. Well, here is a unit circle quadrant 1 chart of values. We're going to be using this throughout this video. I'll make reference to it on occasion. And it's something that you want to be familiar with. Go ahead and take a picture of it if you want, so you can refer to it as we go throughout the video. We're going to start by looking at radian measures that are coterminal to pi/6 values. And I'm talking about everything that has a theta hat of 30 degrees. In particular, we're talking about 30 degrees, 150 degrees, 210, and 330 degrees. And the related radian measures, pi/6, 5pi/6, 7pi/6, and 11pi/6. I do want to mention that 6pi/6 could be thought of as pi, and we could think of 2pi as 12pi/6. You'll see why this is beneficial. Take a look for a moment at 5pi/6 and 6pi/6. Notice that 5/6 is just barely less than 6/6, and so that's why 5pi/6 is in quadrant 2. Likewise, 7pi/6 is greater than 6pi/6. That's why it's in quadrant 3. We can find coterminal values by doing one full extra loop around the unit circle. And in terms of sixths, that means adding 12pi/6. And we can add that to each of the values throughout the unit circle. The pi/6 and 12pi/6 is 13pi/6. 5 plus 12 is 17pi/6. 7 plus 12 is 19pi/6. And we see in quadrant 4, 23pi/6. We could actually continue going around the unit circle that way and adding more and more to it, but we can also go in the negative direction. -30 degrees, -150 degrees, -210, and -330 degrees, all the way around into quadrant 1. And the radian measures are -pi/6, -5pi/6 in quadrant 3, and -7pi/6, quadrant 2, and then in quadrant 1, -11pi/6. And we could also think of negative pi as -6pi/6, and -2pi as -12pi/6. In fact, we can continue on one full revolution and add a -12pi to a -1pi, -13pi/6. Or -12 and -5 is -17pi/6 in quadrant 3. Let's now look at some coterminal radian measures to angles that are related to pi/4, where theta hat is 45 degrees. We know that we have 45, 135, 225, and 315 degrees around the unit circle. And the radian measures are pi/4s, pi/4, 3pi/4, 5pi/4, and 7pi/4. As before, we can rewrite pi, but this time in terms of fourths. So it's 4pi/4. and 2 pi can be written as 8 pi over 4. That means that if we want to go around the unit circle more than once, we can add 8 pi over 4 to any one of these values. We get 9 pi over 4 in quadrant 1. 8 and 3 is 11, so 11 pi over 4 in quadrant 2. Quadrant 3, 8 and 5 is 13, so that's 13 pi over 4. And in quadrant 4, 7 plus 8 is 15, 15 pi over 4. And as before, we can also go in the negative direction. Negative 45 degrees, negative 135 degrees, negative 225 degrees in quadrant 2, and negative 315 degrees in quadrant 1. And similarly, we have the radian measures, negative pi over 4, negative 3 pi over 4, just in the opposite direction of the positive, of course. Negative 5 pi over 4 in quadrant 2, and negative 7 pi over 4 in quadrant 1. Let's do the same for radian measures related to pi over 3. That's where theta hat is 60 degrees. So let's first put the degree measures around. 60 and 120, 240 and 300. And the pi over 3 values, 2 pi over 3. Yes, at 180 or at pi, we have 3 pi over 3, 4 pi over 3, 5 pi over 3. And 2 pi this time is 6 pi over 3. So in terms of thirds, 2 pi is 6 pi over 3. And so we can add that to 6 pi over 3 over and over to get coterminal values. 7 pi over 3, 6 plus 2 is 8 pi over 3. 6 plus 4 in quadrant 3 is 10 pi over 3. And in quadrant 4, 5 plus 6 is 11 pi over 3. And of course, we can also do the negative angle measures. These are familiar to you, negative 60, negative 120, negative 240, negative 300, and negative radian measures as well. All right, now let's take a look at the radian measures related to pi over 2. We're talking about axial measures now at 90 degrees and 270 degrees. So we have pi over 2, and 3 pi over 2. We can also consider 2 pi over 2 at pi and 4 pi over 2 at 2 pi. Notice if we wanted, we actually count around rather easily. Pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and 5 pi over 2. We also have negative angle measures, negative 90, negative 270. And in general, negative pi over 2 and negative 3 pi over 2. But if it's helpful, we could also think of negative pi as negative 2 pi over 2 and negative 2 pi as negative 4 pi over 2. And now we look at angles related to pi, actually starting at 0, and pi at 180 back to 2 pi at the same location as 0. We go back and forth on the x-axis. The odd number pi's on the left side, the 180 degree coterminal values, and on the right side are the even numbered pi's. And of course, we can also go in the negative direction, starting at 0 to negative 180 to negative 360. And that would be negative pi and negative 2 pi in their respective positions. So now let's put that all together and find trig values of these different radian measures. So we'll start with each argument here being something pi over 3, which is related, of course, to 60 degrees. And to find 8 pi over 3, I'll start at 6 pi over 3 and count to 7 pi over 3, and then 8 pi over 3 in quadrant 2. So for part A, where cosecant of 8 pi over 3 is in quadrant 2, the cosecant, first of all, is positive. But what about the pi over 3 value? Well, pi over 3 value for cosecant is 2 square root of 3 over 3. So we include that value now, 2 radical 3 over 3, and we have the value, the trig value that we're trying to find, positive 2 radical 3 over 3. What about 13 pi over 3? Well, we can go around the unit circle twice. The second time would be to 12 pi over 3, and then 13 pi over 3 is just one 60-degree angle more. So it's in quadrant 1. And in quadrant 1, the cotangent is positive. But what's the trig value for the cotangent for pi over 3? Cotangent at pi over 3, square root of 3 over 3. So we put that value in. And there's our answer. Now let's take a look at negative 5 pi over 3 on the unit circle. Notice that's in quadrant 1. And of course, tangent is positive in quadrant 1. The value, though, at pi over 3 for tangent is square root of 3, or radical 3, and that's what we get for our answer, positive radical 3. All right, each of these arguments has a radian measure over 6. That means that theta hat for each of them is pi over 6, or 30 degrees. So we're going to find where 13 pi over 6, 17 pi over 6, and negative 7 pi over 6 are. First of all, again, starting with full 2 pi at 12 pi over 6, 13 pi over 6 is just 30 degrees more, quadrant 1. 17 pi over 6, 17 from 12 is 5, so that's the same location as 5 pi over 6. And the negative 7 pi over 6 is also in quadrant 2. So let's see. 13 pi over 6 is in quadrant 1. The 17 pi over 6 is in quadrant 2. And so is the negative 7 pi over 6. And secant, back up to letter A, the secant in quadrant 1 is positive. And letter B, cosine in quadrant 2 is negative. And letter C, the sine in quadrant 2 is positive. Now, I'm not going to refer back to the unit chart specifically in this video, but I have it in front of me. We see that the secant at pi over 6 is 2 radical 3 over 3. So we get positive 2 radical 3 over 3. The cosine at pi over 6 is radical 3 over 2. But it's negative radical 3 over 2. And the sine at pi over 6 is 1/2. So we get positive 1/2. Okay, all of these arguments have a denominator of 4, so theta hat is pi over 4, or 45 degrees. Let's locate 15 pi over 4, negative pi over 4, and negative 7 pi over 4 here in the unit circle. Well, notice that 8 pi over 4 is the 2 pi, and if we go a full circle around again, it's the 16 pi over 4, and yet we're trying to find 15 pi over 4. So it's almost the 16, just a little bit shy. It's at the 45-degree mark in quadrant 4. Negative pi over 4 is also at that same location in quadrant 4. And negative 7 pi over 4 is in quadrant 1. So let's put those with the trig functions. Letter A, 15 pi over 4, we see is in quadrant 4. In B, negative pi over 4 is also in quadrant 4. And in C, negative 7 pi over 4 is in quadrant 1. The cosine in quadrant 4 is positive. In part B, the cosecant in quadrant 4 is negative. And in part C, the cotangent in quadrant 1 is positive. The cosine of pi over 4 is root 2 over 2, so this becomes positive radical 2 over 2. Cosecant at pi over 4 is square root of 2, so that's negative square root of 2. And the cotangent at pi over 4 is 1. So we get positive 1. All right. Now these values, negative pi over 2, 5 pi over 2, and negative pi, are all axial angles, axial radial measures. And theta hat doesn't apply here. So what we might need to do is look at the actual x and y coordinates for each of those axial values. The 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Once we have those in place, it's then relatively simple to find these particular trig values. Radian measures of negative pi over 2, negative pi, and 5 pi over 2, which you'll notice if we write 4 pi over 2 first, then we can easily find 5 pi over 2. Now in part A, to find the secant, the first thing I'm going to do is actually find the cosine, its reciprocal. And the cosine of negative pi over 2 is the x value is 0. But secant is the reciprocal of that, 1 over 0, and that's undefined. In part B, the tangent of negative pi, well, tangent is sine over cosine. And if we look at negative pi, the sine value is the y, it's 0. Cosine is negative 1, and the fraction 0 over negative 1 is 0. So the tangent is 0. And in part C, sine of 5 pi over 2, that sine is just the y value, which is positive 1. And cosine of negative pi, cosine is the x value at negative pi, which is negative 1. All right, now we're going to do something a little bit different. This time we're given the trig